Okay, so we're going to go over a couple of one-dimensional projectile motion problems. There are two different types, and we'll go over both of those different types. So here are our kinematic equations off to the side. So these are the equations that we'll need in these types of problems. So we'll go ahead and go through this first one. We have Bob, who is practicing juggling, and he throws a ball straight up into the air and then catches it at the same height it was thrown. So it's important to note that it comes back to the same height and not a different height. That tells us that delta y, our displacement, our total change in position, is actually 0 because it just returned to the same spot. So y final equals y initial. And then it reaches a maximum height of 1.5 meters, and it takes 1.2 seconds to get back to his hand. So what was the initial velocity of this ball? So let's say that we have Bob here, and he's doing his juggling act. He throws this ball straight up into the air. It reaches a maximum height here, and then it falls straight back down. So we know that the total time it takes is 1.2 seconds. We also know that the height that it gets to, the maximum height it reaches, is 1.5 meters. So how can we find the initial velocity? We know the time, we know the distance it traveled, and because this is a free fall problem, a projectile motion problem, we know our acceleration is going to be g, which is 9.8 meters per second squared. Just looking at our first equation, we have delta y, we have v initial in the equation, we have the time and the accelerations. So we can use this one because we don't know what the final velocity is. So let's go ahead and use this, and we'll solve for the initial velocity. So we have delta y equals v initial times time, and then plugging in plugging in negative g, since g is directed downward. We have negative 1/2 g t squared. We know that our total displacement, delta y, is 0, so we can just plug in 0 here. We have v initial t minus 1/2 g t squared. So let's move 1/2 gt to the other side, and then we will divide both sides by t. So that's going to give us v initial t equals 1/2 g t squared. We have t squared on one side and then another t on the left, so let's just cancel out one of those. So divide through by t, right? So that gives us v initial is equal to 1/2 g times t. So that's just 1/2 times 9.8 meters per second squared. Don't forget your units. Times 1.2 seconds. And that is going to give us 5.7 meters per second. And that was the initial velocity of the ball. Okay, so that's just this first type of projectile motion problem where something is thrown up and then it falls back down. So let's look at the other commonly used type of 1D projectile motion problem. All right, so our other type of problem is where something is dropped from some higher point and then falls to a lower point, and there's no throwing it up. So here we have Lacey is in a treehouse, and she drops a candy bar down to her sister, who's on the ground. So her sister catches it at exactly 4 meters below where it was dropped. So how long is the candy bar in free fall? So we're looking for the time. And then what is the velocity of the candy bar right before it's caught? So this is our final velocity. Okay, let's draw what we know here. So we have Lacey up here on this tree, or on this tree house. And then we have her sister down here. All right, so she's dropping this candy bar, and it's falling downward. And then Lacey, with her very long arm, reaches out and catches this candy bar. So what we know is that the candy bar falls 4 meters. We also know that it was dropped. And when you see the word drop or dropping in a physics problem, especially a projectile motion problem or a conservation of energy problem, what they're basically saying is that the initial velocity is 0 meters per second. So that actually gives you the initial velocity. If it had a non-zero velocity, they would say it was thrown down, you know, at some velocity. But when they say dropped, they mean the initial velocity is 0. So we have the initial velocity and we have the height, or the distance that it falls, right? So the first thing we want to do is find the time. So we could use delta y equals v initial t plus 1/2 at squared. So let's go ahead and do that to find the time, and then we'll find the final velocity. So delta y equals v initial t plus, well, so then it's going to be minus 1/2 g t squared, because as always, g is negative. So delta y, because the ball is falling downward and we're starting off at some higher point and it's falling down, delta y is actually -2. So we're going in the negative y direction. So delta y is negative as well. We know v initial is 0, which means this whole term here cancels out. So that goes away, and then we just have delta y equals 1/2 g t squared, right? Our negative signs cancel each other out. All right, so now all we have to do is solve for t. So we'll just multiply both sides by 2, divide by g, and take the square root. So that's going to give us 2 delta y over g, take the square root. And so there's a couple of things I want to mention about these types of problems. So you could technically just memorize t equals the square root of 2 delta y over g. But I really don't recommend doing that, because this is specific to this problem. The best way to go about physics problems is to look at this general set of equations, these 4 equations here in projectile motion, and then you can do any problem, any projectile motion problem, based just on that. But you just have to look at the situation instead of making yourself memorize like 20 different equations. Just memorize these 4 and just learn the process of figuring out what's going on and understanding what's going on in the problem, right? So anyway, I will go ahead and plug in our values here. So that's the square root of 2, and then we have 4 meters. We already accounted for the negative sign, so then we have g equals 9.8 meters per second squared. And this is going to give us 0.90 seconds. All right, so now we know the time. What we can do now is just use one of these other equations to find v final. Now the easiest thing we can do is just use v final equals v initial plus at, right? So v final, which is what we are looking for, equals v initial. We already know v initial is 0, right? So 0 plus at, but we're using g, so that's negative gt. So 0 goes away, and our v final is just negative g times t. So that's negative 9.8 meters per second squared times our time, which we just found. And that is going to give us a final velocity of 8.8 meters per second. So this is negative, and that's okay. That's because it's falling downward. It's falling in the negative y direction, so we have a negative velocity. You can have negative velocity. You cannot have negative time in these problems. So our answers look good, and those are our 2 examples of 1D projectile motion. They're all going to be some variation of that pretty much. You're either throwing something up or you're dropping something. No motion in the x direction. Usually it's in these one-dimensional projectile motion problems, it's usually just going up or down. Hopefully that was helpful. Let me know in the comments if there's anything else you'd like to know or see. Thank you.